Hello everyone and welcome back to the channel. In 2023, the Emotet botnet started sending emails with attachments over 500 megabytes. Why? Because most security sandboxes are configured to ignore files that large to save on processing power. Scanning a 500 megabyte file bit by bit is resources heavy and slow. Attackers know this, so they bloat their malware to force security tools to skip the scan entirely. Today we are going to recreate that exact technique and more importantly show you how to detect it. Before we add the weight, let's see how most popular security scanners handle our naked malware. I'm generating the payload now, a simple unencoded reverse shell. I'm uploading our 7 kilobytes small malware to VirusTotal. Since we haven't used any obfuscation or bloating yet, I expect this to be flagged by almost every major engine. It's a signature-based detection nightmare. As you can see, the result is terrible. The detection score is 50 over 70. No company would ever let this file into their network. But what happens when we change the size of the file? Now we are going to perform the actual bloating. We will take a copy of our small malware and add zeros until it reaches 500 megabytes. I'm using the dd command to pull data from div0 by using the double arrow append operator. I'm sticking 500 megabytes of zeros onto the back of the file. This makes the file huge, but because the zeros are at the very end, the malware will still run perfectly. Look at that, our 7 kilobyte file is now a 500 megabyte giant. To a human it looks suspicious, but to an automated sandbox that has a limit, this file is now invisible. I uploaded the 500 megabytes bloated file to VirusTotal. and look at the results. The score dropped to 35 over 66. Why did this happen? It's simple. Every antivirus engine has a limit. Scanning a massive 500 megabyte file bit by bit takes a lot of time and CPU power. To keep your system running fast, many engines are programmed to skip files that exceed a certain size. We forced several security tools to ignore it entirely. Think of it like a security guard at a mall. It's easy for him to check a small handbag, but if someone shows up with massive shipping container, he must just wave them through, because he doesn't have the tools or the time to search the whole thing. That is exactly what we just did to these antivirus engines. Look at the raw map in PA-BEAR. The tiny sliver at the top, sitting right above the red dotted line, is the entire functional malware. That strip is the only part the program actually needs to run. Everything else, the massive empty gray box, represents 500 megabytes of bloat. It is essentially a giant tail of zeros attached to the end of the file to inflate its size. To the Windows loader, the red line marks the end of the real file, so it ignores the rest. However, an antivirus scanner sees the whole box as one giant file it must process. This visual demonstrates why many scanners simply give up and skip the file entirely to save on system resources. Notice the contrast here. Compare the raw box, which is mostly gray junk, to the virtual box next to it. The virtual map shows what actually gets loaded into memory, and as you can see, it's just the small colored sections. Everything below that red line is what we call the overlay. This data exists on your disk, taking up space and triggering size limits, but it never actually enters the computer's memory when the malware runs. Now look at the sidebar. Below all the standard sections, you will see this node called overlay. When we click it, PA-BEAR highlights the 500 megabytes of zeros we added earlier. This is not part of the code. It is just junk appended to the end of the file. By clicking here, you can see exactly where the real malware ends and the bloating begins. So now we've seen how easy it is to take a standard piece of malware and hide it inside a 500 megabytes. By using the same technique as the Emotet botnet, we forced multiple antivirus engines to skip our file, just to save on system resources. This is a clear reminder that size limits in security tools can be a double-edged sword.